Hello everyone, today we are going to see about generative AI image restoration. Image restoration is a critical area of computer vision that focus on improving quality of degraded images, removing unwanted things and recover lost details. This project focus on image denoising using deep learning based fix to GAN architecture with the unit generator and a patch gen. A bad set of noise and a clean image is used to train the model where the unit generator learn to remove noise through encoder and a decoder. Futures extraction with a skip connection and a patch GAN discriminator evaluates image realism at the patch level. The model is trained using combination of laws and L1 laws to preserve fine image details while performing evolution using PSNR matrix. After trained, the best performance model is saved and integrated into user-friendly Tinkinder GUI that allow user to select noise image and instantly see the denoised output. The practical application of deep learning for real-time image restoration. During testing, the system takes a noisy image or degraded image and it will send the output of restored image with the improved clarity and reduced noise. Let's see the black diagram for this project. First, we need to import the image and we need to train that images and then we need to select the model and simultaneously we have to give noise image and denoise image. Once the algorithm learn, we will get one model. By that model, we are going to test our final images. Let's see the train code. This is our train code. First, we need to import required libraries. Here we have used Torch Vision, NumPy, TKDM, and Math. And then we need to set the dataset path. This is our dataset path. Once the dataset loader, we need to give the targets folder names. Here we have clean image and a noisy image. We have to give that both images. And then we need to transform that image. We need to resize that images. Once the image resizes, it converts into float. And then we need to select the model. You can see here we have used the unit generator, patch discriminator. Once the model learn, we will get PSNR. PSNR is like accuracy. If the PSNR is above 25, the model learned clearly. Then we need to train. Here we have given epoch equal to 100 and batch size equal to 8. And image, we have resized that image 256 into 256. Once the model learn, our best model will save here. You can see here gbest.pth. This is our best model. By this model only we are going to test our image. Let's see the test code. This is our test code. Here you can see these are the required libraries. For GUI, we have used Tinkinder GUI and then we need to set the dataset path. Once we test the image, it will store in this path outputs and then we need to select the algorithms. Again, we need to resize the images and you can see here we have given image files, image formats, PNG, JPG, JPEG. These are the image formats we have. And here you can see build Tinkinder window. This is for Tinkinder size here given. Let's run this code. Yeah, here you can see this is our GUI. You have to select here. Yeah, this is our data sets. You can see clean image and noisy images. Let's upload any image. Here you can see this is our noisy image and this is our denoised image. Let's select any other image. Yeah, here you can see this is our noisy image and this is our denoised image. Let's select any other images. Yeah, that's all. Thank you.